Okay, now we can go ahead and set each of these equal to 0 to solve for x. And we're going to get x minus 2 equals 0 with x equaling 2, and x plus 5 equals 0 with x equaling negative 5. Now these two values of x are our zeros of the function, or our x-intercepts. So if we actually looked at the graph here, we would see something that was sad face because we have a negative leading coefficient, and these two intersections with the x-axis are x-intercepts of 2 and negative 5. Awesome. Let's look at one more example here. We got example 3. A projectile launched upward with a speed of 60 meters per second. Its height, h meters after t seconds, is modeled by the equation h equals, that should be a negative 4.9 t squared plus 60t plus 1.85. So if you remember at the beginning of Unit 3, I did talk about projectiles model quadratic functions. So for example, if you start at a point and then you threw something up in the air in the forward direction, it would go up and hit a maximum height and eventually come down and land somewhere. So what we're going to look at right away with this example will demonstrate what I was talking about earlier. So part A says graph the quadratic function. Hint: use graphing calculator for coefficients with decimals or fractions. Just like in this example, it has coefficients with decimals. So if you ever come across something that has decimals or fractions, please go ahead and use your graphing calculator to take a look at what the function looks like. So we're going to do that. I'm going to pull up our graphing calculator here, turn it on, and it's already in the y equals there for me. Perfect. So let's insert our equation here. We have negative 4.9, and even though the variable here is t and h, in the calculator it only uses x and y, so we're going to use x squared, but it'll be the same, plus 60x, and then plus 1.85. Now to look at it, we go over to the graph, and we can't really see it, can we? We can see that though it got a little darker in the middle, so that our graph is there, but since our window is so different than what the graph needs, we need to alter that. So let's go to the window, and we're given a window of negative 10 by 10 in both directions. Well, from what I can see is our graph's going to go way higher than a max of 10. So let's go down to our y max and give it a much larger number. For example, 200. And maybe change our min a little bit too. Maybe make it a little smaller at negative 20 or something. And let's alter our y values too. Let's make this a little bigger to 15 and a little smaller with negative 5. Let's see if that will give us a better view of our graph here. Alright, so go back to graph. Ah, voila, we can see it now. There is our function. So I'm going to use a little trick here, and I'm going to actually take a picture of our graph there and put it onto our notes here. So I'm going to go and click on second, and I'm going to take a screenshot, save it on my desktop. I'm going to go back to the notes here, and I'm going to insert picture, and there it is. Let's make it a little bigger. Perfect. That is what our graph looks like here for this function. So what does part B want from us? It says identify and explain the significance of the intercepts, the coordinate of the vertex, and the domain and range. So let's take a copy of this and bring it down here so we can take a look at it while we're determining some of these properties. So first of all, let's identify the intercepts, the coordinate of the vertex, and the domain and range. So we want to find out the x-intercepts here, the y-intercept here, the vertex up here, and the domain and range. To find that, we can actually use our calculator here, and it will calculate it for us. So first of all, let's look at the intercepts. Now, if we go second function, trace, it gives us this calculate function. So it gives us a variety of things that we can calculate from our graph. Well, we want to find the zeros, first of all. Those are the x-intercepts, right? So if we go ahead and hit enter for that. Now it's saying left bound at the bottom there. Well, when we're finding our intercepts using our calculator, we have to calculate the left and the right hand side in order to find the actual intercept. So we need to go and move our cursor. This might take a little bit. And move it to the left side of our intercept. So once our y values here are negative, we know that we've crossed the x-axis. So this is the left-hand side, so we can go ahead and hit enter. And now it says right bound, so now we need to go to the right side of the intercept. So go back up, and we have y positive, so we can go and hit enter again. And it says guess, enter again, and it should calculate us out the x-intercept. And there it is. It says that the x-intercept is negative 0.0308 if we round. We got one at negative 0.0308 and 0. And now let's go ahead and calculate the other one. Second function, trace, down to 0, left bound. So here we are yet again going left to right. So instead of below and then above, we're going to start above and then calculate the below. So let's move it to just above the y-axis. It's probably good there, so let's hit enter. Now we got to do the below, and we hit enter again. Guess. And there's our other x-intercept. So I know that the y value here says 1 e to the negative 11. That's actually a calculator error. It is supposed to say 0. So that is our other x-intercept. So here it is 12.2757. So we have another intercept of 12.27570. And those are our two x-intercepts here. What about our y-intercept though? It does cross the y-axis at some point, so let's calculate that. Yet again, going into second function, trace. Now to find the y-intercept, it's a little different because remember when we have our y-intercept, our x, what is our x always going to equal? Well, 0, because it's at the 0 point on the y-axis. So to find the y-intercept, we actually just go into value, and we can type in the value of 0 for x, and it should calculate our y-intercept there, and it is 1.85. So our y-intercept is 1.85. Awesome. Next, we need to find the coordinates of the vertex. Back to our calculator. Second function, trace. Well, in this case, are we looking for a maximum or a minimum value? Well, since we have a sad face parabola, we're looking for a maximum. So we can go down to the maximum button to find our vertex here. And just like before, we're going to calculate the left side and then the right side, and it should give us the vertex. We're there. Enter. Do the right side. Enter. Enter. And there's our vertex at 6.122 and 185.52. So we got vertex. Perfect. Our vertex. Well, lastly, our domain in our range, we can calculate that without using the calculator because the domain for quadratic functions is always going to be all real numbers, and the range depends on the vertex. And since we have a maximum point, we want our y values to be less than or equal to our height here of 185.523. Now that we've identified all of these properties, what is the significance of them? Well, in this example, instead of having coordinates that were supposed to be x and y, we were actually using coordinates of t and h. T being time and h being height. So for our intercepts, we wanted to start at 0 time and then move on to a time when the ball, for example, that we threw in the air landed. Well, our first intercept here has a negative time, so we're going to actually ignore that. That's not going to be our starting point because we want a starting point of 0. Well, our x-intercept here does have a starting point of 0 time. So that would be our initial spot where we were standing. And we were standing at some height of 1.85 meters. Maybe we were standing on top of a ledge or something, and that's where we threw the projectile. Well, as we threw the projectile, it reached a maximum height of 185.523 meters at a time of 6.122 seconds. So that's where our vertex is, our maximum height at the time it met that height. And then our other x-intercept is when the projectile hit the ground because it was at a height of 0. And hence it took 12.2757 seconds for it to reach its maximum height and then come back down and hit the ground again after we had thrown it.